Good afternoon, all of you. Today we are going to discuss the solution for the paper of UT. So the question paper in your UT was question number 1. If Q1 charge minus 5 into 10 to the power minus 6 coulomb and Q2 charge 7 into 10 to the power minus 6 coulombs are separated by a distance of 10 centimeter, then find point C where the net force will be equal to 0. So basically in the question the given data is something like question number 1 solution given is value of charge Q1 is equal to minus 5 into 10 to the power minus 6 coulomb and Q2 is equal to 7 into 10 to the power minus 6 coulomb, and we have to find out the point C at where the net force F net is equal to 0. And one more data is given that the distance between both the charges is R is equal to 10 centimeter. This is what is the data is given in the question, and we have to find out the point C at which position we have to take another charge so that it feels the net force is equal to 0. So let's just draw a graphical representation of the given problem. By looking at the charge, we can say that Q1 is placed at point A and Q2 is placed at point B, and the magnitude for Q1 charge is minus 5 into 10 to the power minus 6 coulomb, and the value of charge Q2 is 7 into 10 to the power minus 6 coulomb. ठीक है, तो ये हमें 2 पॉइंट दे रखे A and B और उन पे Q1 और Q2 चार्ज रखे हुए. The distance between both the charge is 10 centimeter, and we have to find out a point C at where the net force will be equal to 0. This kind of question we have already done in our previous lectures, but again look at the problem. We can understand few things from it, that the point could never be present above or below to the line which is joining both the charges. The reason is, if we put charge here, it will add another force here. A net force could never be equal to 0, because if we took this one is a minus charge, minus 5 into 10 to the power minus 6, if we put here some kind of charge, then it will produce, if it is a positive charge, then it will be feels like force of attraction between A and B or A and C, and here it will be a repulsive force. Here it will be attractive and here it will be repulsive force, but net force could never be equal to 0. So we have to take another option. We have to look at another option, that is that what if we took it on the line which is joining A and B. It could be here or here. Let's see what will going to happen. By looking at the magnitude of both the charges, we can observe that this minus 5 coulomb microcoulomb will be lesser in magnitude, so it will produce less amount of force. So the distance, when we increase, the effect reduces rapidly as compared to this one. Why? Because the magnitude of Q2 is greater than the Q1. So if the magnitude of Q2 is greater, then the point must be lie on the left hand side, of the combination of the arrangement. So this side we could never take, because the greater magnitude will create large amount of force, and here the distance it is larger, so effect of this charge will be lesser. So that is why we are taking here point C on the left hand side or in the side of Q1. Is it clear to everyone? Because Q1 has a lesser magnitude. Q1 has a lesser magnitude, so it will be effective on the lesser distance. And this one has larger magnitude, so it will be work larger distance as compared to the Q1. That is why we have taken here C, so that it could cancel out each other somehow. So the distance between A and B is 10 centimeter. Let us consider that the distance between A and C is equal to x centimeter. Is x centimeter. So here we have a brief ideology that what we are going to do. Now we just have to take simple concept that the force between A and C must be equal to the force between C and B. Then the net force will be equal to 0. So by applying the law of Coulomb's force, we could written it as the force between A and C, FAC must be equal to FBC. Then only we can say that the net force is equal to 0. Okay, because at point C the net force will be equal to FAC plus FBC, and it should be equal to 0, so that they must be have to same value of force. Because the polarity is opposite, so the sign will be automatically negative. Now the value of f of AC could be written as K Q1 Q2 upon R square, and here it could be written as K, we can say QA QC K QB QC upon R square. This is the basic formula. This is the basic formula for the Coulomb's force. Now by looking at the value of charge, here the force between charge which is placed at A and the charge which is placed at the C, and the distance between both is equal to x centimeter. So don't get confused. If you write here R square, what we have already taken in the numerical or the derivation, it will be going to wrong. It will be wrong if we take here R square. So what we have to do, we have to take here the distance between both the charges, and here the distance is considered as x centimeter. So we have to write here that K QA QC divided by x square, square of the distance between both the charges. And here the distance between C and B, the distance between B and C or C and B is equal to x plus 10 centimeter. X plus 10 centimeter. This one is the x centimeter, this one is 10 centimeter. So the total distance between B and C is equal to x plus 10 centimeter. X plus 10 centimeter. So K QB, value of charge which is placed at B, Q of C, value of charge which is placed at C, divided by distance between both the charges, that is equal to x plus 10 whole square. By the help of this equation we can solve and find out the value of x, because K gets cancelled out by the K, QC gets cancelled out by the QC, so the remaining quantities are QA divided by x square is equal to QB divided by x plus 10 square. By cross multiplying, we could take here, we could write here x plus 10 ka whole square QA is equal to x square QB. Substituting the value of QA and QB, we could say x plus 10 whole square, the value of QA is equal to 5 into 10 raised to power minus 6 Coulomb. Don't consider here sign, because we have already taken here that QA must be equal to QB. The force between QC must be equal to the force between QB and QC. So we are just talking about the magnitude. We have already considered the sign. And x square, value of QB is 7 into 10 raised to power minus 6 microcoulomb or 6 coulomb. This micro will cancel out this micro, 10 to the power minus 6 get cancelled out by the 10 to the power minus 6. So the remaining quantities are x plus 10 ka whole square into 5 is equal to 7x square, or we can say x square plus 20x plus 10 square. A square plus 2ab plus b square whole multiplied by 5 is equal to 7 into x square. So this equation could be something like 7x square minus x square minus 20x minus 10 square, and here it has a multiplication factor of 5. Is equal to 5 multiplied by this 5x square plus 25 is 100x plus 5 into 10 square is equal to 7x square. This 7x square will be go here, will be 7x square which is in minus, and plus 5x square plus 100x plus 5 into 10 to the square is equal to 0. So this is a binomial equation. By the help of formula we could derive, or we could find the value of x, that is x is equal to plus minus, or we can say b plus minus under root b square minus 4ac upon 2a. By the help of this formula we can find out the value of x very easily. So this is what all about the question number 1. Question number 2. Derive expression for electric potential due to electric dipole at x distance from center O of the dipole. So question number 2 solution. And question number 2, the given is there is an electric dipole, and what is the definition of electric dipole? The definition of electric dipole is two equal magnitude charges having opposite polarity separated by a very small distance. This configuration is called as electric dipole. Now what we have to do, we have to derive the expression for the electric potential at point P, somewhere at point P, which is x distance from the center of the electric dipole. This derivation is already completed in our previous lectures. What we have done, that we are just taking here that what will be the potential on P due to plus Q charge, and what will be the potential of potential at P due to minus Q charge, and by adding the overall potential we can get final total potential, like V is equal to V of plus Q plus V of minus Q. By finding separated potential due to plus Q and potential due to minus Q, we can get the value of total potential. We have also done few new methods, that this one is considered as x1, this one is considered as x2, and we just draw perpendicular on the PO line from the Q, and also we draw perpendicular on OP line from the minus Q charge, and this one was the C, this one was the point D, and by the help of few trigonometric concept we replace the value of x1 and x2 in the terms of x and A, in terms of x and A. So this derivation is already done in our last lectures. last few lectures, and next question we will discuss in our next lecture.